Oh yeah, all right, it's already started. Okay. So so what I'm gonna do is I'll just yeah, what am I gonna do? Oh yeah. So I'll basically share my screen and I'll just show you the images that I uploaded so that way you can like see them, and so it's like we just look at like the process, we go over it, right? We explain it basically. Yeah, so let me just let me see if I can share my screen. Okay. Let me go to Fly. Yeah. All right. So basically, this is what I uploaded, right? So like for part 2, okay, let me open original. All right. So for exercise 1, like the first, wait, where's this? Oh, okay, never mind. Okay. So the first question is about using bisection method to get the solution that's accurate to within like 10 raised to the negative 5, right? Of that.
Yeah.
Okay. So first of all, when you do this, let's see. And by the way, if I make a mistake, like when I explain this, obviously you can like help out, like, okay.
Okay, bro, don't worry.
Yeah. Okay, so you see the screen, right? You see like the paper that I have.
Right there, bro.
Yeah. All right. So we can just okay, we can ignore this part like at the very top because this is just like proving that it has a solution. We don't have to go over that. I mean, that's like review calc. But here's like the important formula here. By the way, you see the cursor, right? Like the magnifying glass.
Yeah, we can see it, bro.
Okay. So basically here's like more or less a formula you have to know. It's one where it's like 1 over 2 raised to the n. N is like how many iterations you got. And then b minus a, right? So we know what b is. We know what a is. And it has to be less than or equal to 10 to the negative 5, right?
Yeah.
So it's like we already know what, it gives us the interval, right? So we already know what b and negative 2 is, right? So now when I did this, I don't know, I think I was confused because like for some reason it was something where like I put 0 here and then minus, I don't know, I thought of it like negative or some shit like that. Oh wait, this is supposed to be plus, right?
I'm not sure, bro.
Because when you plug in, no, I'm saying like when you plug in 0, right? It's 0 minus negative 2, right? So that's plus 2.
Yeah. So it's +2.
Yeah. Okay. And then you solve for for n. That's all it is, right? It's a little complicated because it's like you're solving for an exponent thing. So it's like you got to use
Natural
I gotta
log.
flip things over, right? So I think what he did here, or well, what I did, I was trying to, so I flipped it over like that. So notice how like it's like 2 over 2 to the n, and then it's 2 to the n over 2, right? You just flip it over. Same thing here. And so now it's like this is gonna be greater than, right? Than that. And so then you divide, you multiply both sides by 2, and then you do the natural log thing. So that way you get bring down the exponent and everything. And so basically that's what you do, right? And just in case anything gets negative, it's all going to be positive, right? Just make absolute value. So then 17.6 n has to be 18, right? So more, does that make sense to you guys? Yeah. So all you have to do for this one is just memorize this 1 over 2 to the n b minus a, and if you figure that out, that's pretty much it. That's all you have to know.
Yeah.
Which exam is this for?
Oh, this is exam 1 part 2.
Exam 1 part 2. Okay.
Yeah. Oh wait, let me actually see who's here right now. So I noticed. Okay, Simon's here. Jorge, what's up, man?
What's up? I just got here. Sorry for being late.
Yeah, it's all right. No, actually, wait, let me look at. I'm pretty sure it's already like recording. I think. Yeah, it's recording because it has like the red dot, right? You see it?
Yo, Gerardo,
Yeah.
for me, I didn't do b 1 over 2n times b minus a. You feel me? I just did 1 over 2n. I got 17 and he still marked it right. Is that right or?
Wait. Wait, so you just put it's just 1 over 2n? That's all you did?
Yeah. So what do you think it could be?
No, I mean, if anything, he probably, I don't know, he probably graded that wrong, I guess. Because this is like the correct way to do it. Like this is like the formula for it. You know what I mean?
Okay, if that's
And
the
so,
formula, I'll use that one then. B minus
yeah,
A.
yeah. I mean, I got it right here, right? It gave me 10. So
Yeah.
I think that's correct. Whatever. Okay, so another thing too is also that you have to like do like at least 2 iterations of the bisection method in order for it to so you get full credit out of this, right? And so you do this, right, where it's like, okay, A is -2, B 0, and then the midpoint, right, P0 is -1. And so, you plug whatever it is into the function, just so you know whether it's positive or negative. And then depending on that, then you get to choose like what are the next like what's it called, like the 2 endpoints, right, like A and B, right? That's the idea. So you just have to do 2 iterations of it. And so now you have to get like, you already have your P0 and then you have your P1. And then basically saying like, keep doing this until you get a P18, right? Right, that's all you have to say, like continue this. But you have to at least show 2 iterations where you actually like write it out, right? So
Yeah.
okay, and if you do that, you'll get full credit. That's basically it. So yeah, that's pretty good.
Yeah.
All right. Okay, so let me just close this out. Okay, so the second question was about fixed point iteration. Basically, it's the exact same thing as question 1. It's just saying, okay, this is the new method, right? Fixed point. So let me just pull it up right now. Okay, let's see. No, I didn't do that on purpose, but I just saw that shit. Okay. That was not on purpose, bro.
Yeah, for sure, bro.
Yeah. Okay. Yeah. So here it is, right? So here's our function. Here's the interval. It has to be 10 to the -7. So it's fixed point, right? So it has to be about like the g of x thing, right? And
Yeah, that's when you turn G of X.
Right. So basically, like this is true if g of x equals x, right? So the idea is basically like it's so like when you plug in that number, it's going to equal that number when you plug into the function, right? It's kind of like the function y equals x, right? So you plug in 4, you'll get 4. You plug in whatever, like it's the same idea, right? But obviously not every function is like that, right? I don't know, maybe, certain functions, it's like you plug in like, like say some weird ass number and you'll get that same number again, right? After you like evaluate it and all that. So that's all this is. So you're trying to find a g of x that's like this, right? So basically what you need to do is you go to the original function here and you solve for x, right? You solve for like, you get x all by itself and then all this other stuff on the other side. So you see here that, you move this stuff to the right side. So it's x to the 4 equals x plus 10. Take the 4th root on both sides, and that's your g of x, right? Because g of x is x. And so you can just substitute, right? G of x equals this, right? Does that make sense?
Yeah.
Yeah. All right. So so we get to this point, right? We have our g of x. Now we have to do g prime. And so taking the derivative is pretty easy, right? So the whole point for this is that you're trying to figure out if like within that interval, right? Because the interval is what's important, right? So you want to figure out if your derivative is always going to be like within like -1, +1, right? For the like within that interval, right? So the interval here is 0 to
It's 0 to K to 1, bro.
Yeah, that's right. Like it has to be within like 0, 1. Honestly, it could be positive or negative. Doesn't matter, right? Because it's just gonna be absolute value. You know what I mean?
Yeah.
Yeah. So it's like you do this, and then easy way to do it is just you just basically find the way to make the derivative as big as possible, right? And then ends up being just that, right? Which obviously that's less than 1, so that's good, right? You check that negative, no, not negative, but absolute value g prime is less than 1, right? It's always going to be that, right?
Yeah.
So then the next thing, and yeah, it seems like I got full credit on that. Let me see. Yeah, it was 15 points. Yeah, I got full credit. Okay, wait, let me. Okay, so then the next thing you prove is is that you have to prove that, wait. Oh, wait, someone just texted, or, no, that's some other shit. Okay, so then after you do that, you have to show basically that like basically from 0 to 4 in this case, because that's the interval we have, from 0 to 4, the function is always increasing, right? That's another thing you have to prove. But the thing is that it's very easy because all you have to do is just prove that the derivative is always positive. You understand what I mean? Because when the derivative is positive, it means the function's like going up, it's increasing, right? And so you can just say, like, you don't really have to like prove anything, you don't have to write anything out. You can just say, G prime is always greater than 0, like within the interval. And so I can say G of 0 is less than G of X less than G of 4, right? That's basically like what it boils down to, right? You just have to make that statement. And so if you have the two statements where G prime is always less than 1 or less than or equal to 1, and the function is always increasing, that's basically what this statement is. And if you make those two statements, then you basically are good. And that means that now you can do fixed point iteration, right? So the whole point is that you have to prove that both of those things are true. You know what I mean? Okay. And then the third thing that you have to prove is you have to prove that that basically like what am I trying to say? That basically like the interval as far as like the X values is from 0 to 4. So it has to be the true for Y values, meaning that you can't have a Y value that's greater than 4 or less than 0, right? That's another thing you have to prove. So you plug in, 0, you get 1.77. Okay, so that's within the interval of 0 to 4. Same thing with G of 4, which is also within 0 to 4, right? Because it's 1.99. And so the function G of X is within 0 to 4. So not only is the interval 0 to 4, but also the range, right? Like the Y values, it's also within 0 to 4. Okay, so you have to prove all three of these things in order for the fixed point iteration to work, right? You have to prove all these things first. So does that make sense?
Yeah.
Yeah. What about you guys? Right, because Sam was the only one like agreeing.
Yeah, I got it. I was seeing my exam too, and I had the question right. Yeah, I just have to review it. But yeah, I get it.
Yeah. So after you prove that stuff, then you go straight into the fixed point thing. So you have K to the N max. Basically you pick the one that's like the biggest, essentially. It doesn't really matter like which A. No. Well, A and B, yeah, that's already settled. But like you have to find like a P of N, basically just some value within that. So you can just pick like like 0 or 4 in this case, right? It doesn't really matter. So you do that. Okay. So your K is going to be 0.04 because that's what this is, right? That's like the highest, like that's as great as the derivative is going to be, right? That's the idea. And so that's your K. And so your P0, it doesn't really matter which one it is, as long as it's a number that's within the 0 to 4, you're good, right? That's all that really matters. So just to be convenient, you can just plug in you can just substitute A or B into the P of 0, and that'll be okay. So then you plug it into the formula. And by the way, all this has to be less than or equal to 10 to the negative 7, right? Because that's the accuracy of 1. So we have to use that. And so you solve for N just like we did last time. So this is just like algebra. And then you get this number, so you round up to 6. And then just like before, you have to show some iterations, right? And so it's very easy here. You can just say like, you already have G of X defined, right? So you can just say like P of 0 is 0. You just have to pick a number within 0 to 4. And you can say, well, P of 1 is just G of P of 0. And then P of 2 is G of P of 1. And then with at least those two iterations, you're good. And now you have full credit, right? Does that make sense?
Yeah.
Okay. And then we had another one. All right, let's see. Why am I? Oh yeah, let me just yeah. Okay, and then all right, so the last question was okay. Wait, I already have this open. Okay. And the last question was to prove that this function 3 to the negative x has exactly one fixed point within 0 to 1. Okay, so we have, so it's fixed point again, but this time it's like just to prove that it has one fixed point within that interval. Okay, so let me just pull this up. Okay, let's see. All right, so now not much work here. Okay, wait, wasn't this the question that we were confused about when we took the exam?
He gave it to us regardless, yeah. Because we
Yeah.
couldn't get that it was like it was always negative or something like that.
Right. Shit, that
Oh,
yeah,
yeah.
that threw us for a loop, right? How about this? You know, we can pretend. Well, I mean, it doesn't really matter because obviously, like, we understand the concept. It's just that there's an error in the exam. So, I mean, we can still explain this, but it could work if it were like 2 raised to the negative x. That would be okay,
Yeah.
right? So, but it doesn't matter. It's not a big deal. So it already gives us the g of x, so we don't have to find it, but we had to find it for question 2. So you take the derivative of this, right? So that's your derivative. And then you have to find out if your derivative, like basically like find like the highest value for your derivative and see if it's like greater than, if it's greater than 1. And if it is, then obviously, you know, it fails, right? So 1.1 obviously is less than 1, right, guys? So basically, yeah, you know, that condition is satisfied, right? Wink, wink. And you all you have to say is that, well, the derivative is always negative. I'm sorry, the derivative is always negative, so you can say that g of 1 is less than g of x less than g of 0. Basically like the derivative has to be always positive or always negative within that interval. That's the point. The point is that it can't be like, you know, increasing and then decreasing, you know, in the interval. It has to be like all the way positive or negative, right? So that's the requirement there. So again, it doesn't really matter. You just have to like here, by the way, let me just explain, like, if the derivative, let's say, is always going to be negative, let's say if it's like a negative sign in front of the derivative, or if it's positive, that's what's going to tell you, you know, whether it goes from, as far as like in what order this is going to be, right? So let's say if the derivative was positive, g prime, let's say, is greater than 0. So that would mean that it would be g of 0 is less than g of x is less than g of 1, right? But it's negative, so it's like the reverse. You know what I mean?
Mm-hmm.
Yeah. And then same thing, you just have to show that the range is within g of, well, it's within like 0, 1, right? And so you plug in g of 1, you know, something greater than 0, plug in g of 0, it's something that is, it's 1, right? So basically it's within the interval, so that's good. Okay, so you prove those 3 things, and then you go into the fixed point, right? So for this one, wait a minute. Wait, why do we, oh, okay, now I see it. Okay, so basically what it's saying is that, so we have to find out like the iterations to get it, and then obviously we don't have to actually like find the fixed point, but the idea is that, you know, if you do it this many times, you'll get your the solution, right? So so again, same thing with exercise 2. So your k is going to be like your smallest derivative. Obviously, like, we didn't get that, right? We have no idea what it is, but that's what k would be. Same thing here, you know, you can just plug in like 0, for example, right? And okay, so that's basically it, right? So your max is going, well, for this one you don't really see max, right? It's just 1. And so and you get, yeah, so obviously this is wrong, right? Obviously n is not that, but you get the idea, right? Like in theory this is how it's supposed to work. It's just that we ended up with a weird, you know, he messed up the exam, I don't know. But this is what you're supposed to do. So whatever this n is, you would basically round it up, you know, just like we did. You give some iterations, like, okay, you do this where it's like, you know, g of, you know, like p of 0 goes 0, and then p of 1 is g of 0, p of 0. Same thing, right? You do the same thing just to show some iterations, and then that's it, right? And you have to specify you're going up to p of like 97 in this case. So is that good?
Yeah, bro, of course.
Yeah.
Hopefully he doesn't make a mistake this time though.
No, I hope he does, bro, so we can get some free
Oh,
points
yeah,
for
it's
it,
true,
right?
it's true, it's true, yeah.
Yeah. Okay. I don't want to go over like every single thing. Like for this class, like today, I want to do like half of the material, right? So is that good with you guys, or what?
Yeah, of course.
Yeah.
All of it is too much.
For sure.
Yeah. So basically, yeah. So let me just, okay. So we went over example 1. That's pretty good. So now let's go over So just like I did before, I'll just, like the exam questions. That's how it's gonna work. So.
Gerardo, you fly away, bro?
It's just that I'm taking a picture of like a perfect score. So it's like, if you want to, you could also like send them in the group chat, right, on Discord.
Yeah, you get, bro.
Yeah. All right, so. By the way, how do I say your name? Like Jorge or George?
Doesn't matter, bro. George, Jorge, whatever. Doesn't matter, bro.
Yeah. Yo, so how many finals you got, bro, this semester?
Oh, me, I have I did one yesterday, so now I have this one, and then I have one more, I think. No, two more. So 3 in total.
Okay. All right. So I have them all uploaded. So let me just let's see. I think I uploaded them on general. Yeah.
Let me did it on the board.
The board. Wait, who's this? Wait, who did that? Homework practice. Yeah. Someone did it on the board. I don't know. Wait, do you know who Jason is?
It's the
Like
guy in the
where?
picture, bro.
Yeah, I know, but like,
To be honest, I don't even know, bro.
yeah, bro, it's fine, bro. It's
He
fine.
doesn't show up to class like all the time, but yeah, I know who he is.
Oh, yo, it's the blonde kid.
Yeah, the blonde kid with the glasses.
Oh yeah. Okay.
The one that looks like he's 50, yeah.
Damn, bro. Roasting him like that. No,
You should-
whatever. Okay, so all right, so here's example 2. So we now we have to do the okay, so first of all, exercise 1 is like a lot of stuff.
For real.
Okay, so Lagrange, where the fuck it is. Yeah, Lagrange shit. Okay, so that's your function, got your nodes. Find upper bound. Okay, yeah, I think 2 and 3 should be okay. All right, let's do this shit. All right, so here's what I got. Wait, let me see if I got, see, the thing is I'm only gonna look at them if I get like a perfect score on them. Obviously, like, if I have like, let's say like not a perfect score on them, then obviously I wouldn't like show them to you. You know what I mean?
No,
So
you-
like, yeah. So, by the way, you guys also have your exams too, right?
yeah, I have it right
Yeah.
here with me.
All right, bro. Okay, so here we go. So, all all right, so part one of of one, basically, your P of X is L0x, F of X 0, right? Basically, like this is the formula, right? And you do it like for how many nodes you got, right? So the Lagrange thing is basically like it's just X. It's always gonna be like X on these two guys here, right? Like on the top left side of each of these like parentheses, you always have an X on the top left, right? Minus, and the 0 here is just telling you like the 0th node, right? And I think it said that, yeah, that's basically what it means. So basically the 0th node always pops up down here, right? Or like L of 0, I'm sorry, like, or if it were like L of 1, it would be the 1th node, you know what I mean? Or well, the first node, but it's like 1, right? Because it doesn't start with 1, it starts with 0, you know what I mean? So this one, so L of 0, we're talking about the first node, right? And so if it were L of 1, it would be down here, you would actually see, 0.5, you know what I mean? And so down here we have we have 0 here consistently because that's our 0th node, right? It's 0. Okay. And then on the right hand side of these guys, on both the top and the I guess I can talk. On both the top and the bottom, you have basically that other node, right? That's not the one that's shown with the L, you know what I mean? So the rest of them would just be like the 1 and the 2 node, right? And so this one's 0.5, 0.5, 1, and 1, right? So this guy is like the X1, and this one's the X2, right? The 0.5 and the 1, right? So that's basically more or less how the formula works. And so here it's always going to be X here, right, on the top left. Right underneath it is always going to be like whatever node this number is referring to. So it could be like 0, right? And like I said, on the right side, it's always going to be like that other node, right? And you're going for each of them, right? And so since there's 3 nodes in total, that's why you only have 2, like 2 of these guys, if that makes sense, right?
Of course, yeah.
Yeah. And so it's like that's basically it. And so it's basically like a lot of like plugging in, right? But as long as you understand like this Lagrange formula, this should be pretty easy, right? It's not that complicated. So this is just telling you plug in whatever basically the 0th node, plug that into the function. That's all it really is. So it's just plug in 0 in this case, you're gonna get 2. Again, same idea, right? This time it's 0.5, right? That's the node. So it's like, so it's not that hard. It's pretty straightforward, right? So and so like the actual like Lagrange polynomial that you get is basically based on this formula here, right? And so as long as you get that, you're good, right? You basically like, that's all there is to it. So then we get
The
to
error
part
was
2.
kind of long.
What's long?
The error for that one, because we have to remember all the errors, so it's a lot, man.
Yeah, you're right. Okay, so R of X. Okay, this is the remainder. Yeah, that's the one. So for Lagrange, I want to say Lagrange. I don't know why. For Lagrange, for this shit. Okay, so the error for this one is gonna be 1 over. Okay, so basically like n, right? N is not the number of nodes you got. What it is basically like how it is, like it starts with 0. You know what I mean? And so it's like let's say it were like, let's say we only have 1 node, it would be, you would plug in 0 into this instead of 1. You know what I mean? Because n starts at 0, right? It doesn't start at 1. And so in this case, you have x of 0, x of 1, x of 2, right? So in total, you actually have 3 nodes, but you plug 2 into this because of the fact that it ends at x2. You know what I mean? Like that's just how it starts off at 0, and then so you plug in 2, so 2 plus 1, and then basically it's really simple, right? It's just x minus, and then whatever those nodes are. So x minus 0, x minus 0.5, x minus 1, right? It's just you go like that for all the nodes, right? It's really simple. And then at the very end, same thing, right? 2 plus 1 for your derivative of the original function, by the way, not the Lagrange function, obviously, but of the original function that you get, it's the derivative of it to 2 plus 1, right? That's all it is. And your epsilon thing, right? So you make epsilon as big as possible, right? To make the derivatives big, right? So you get your derivatives, and then you finally plug in whatever. Okay, so for this one, you try to maximize how big these x's can be and how big the epsilons can be, so that way you get like as big, like a bigger value. That's the idea. So since we're talking about the interval from 0 to 1, right? Because the first node was 0 and the last node was 1, right? So that's your interval, right? 0 to 1. And so here you just plug in 1. Here you plug in 1, which is 0.5. Here you plug in 0, so that way you get 1, right? Because absolute value. Same thing here. You plug in like 0 in this case. Plug in 1. You're trying to make it all big, right? That's the idea. So you get this value. So that's your error. Okay, that's the error for the Lagrange polynomial thing. Then the last thing is that now you have to find out like if you're going to integrate it, what will be the remainder or the integral of that? Well, it's the same idea, right? All you have to do is basically for your remainder, all you have to do is just simply do the exact same thing, right? So again, basically take this formula that we just did and you just plug it into here and you basically find the integral, right? So the 1/6 comes from the 1/3 factorial here, which is 6. Basically you're just copy and pasting like the exact same formula, but just you're going to integrate it, right? That's all there is to it. And so it's really simple. I mean, obviously it's like all algebra, right? Because you're like distributing and all that, but it's not that bad, right? So it's like you integrate this. And yeah, that's pretty much it, right? So is that good?
Yeah, bro.
Yeah. So really the only thing to memorize from this would probably be, like how to do like the
It's just the formula
Lagrange
and the
thing.
error. Yeah, it's just the formula
Yeah,
and the
the
error.
formula. Yeah, that's right.
L, FO, L1, F1, that shit.
Yeah. Yeah, this one's not too bad. It's not too bad to memorize. The only thing though is that let's say if you have like, because this one gave you 3 nodes, but obviously like n is not going to be 3, it's going to be 2, right? It's just that it has to work that way.
I think it's just n minus 1 plus 1. That way you can remember it.
Or it could just be like n, right? Like,
Yeah.
oh, just plug in here how many nodes you got, right? But I don't know. It's just
I don't even know who comes up with that.
yeah, it's shit, right? Yeah, I know. Okay, so we're done with question. Wait, I think someone someone put something in the. Oh, never mind. No, that was me. No, I uploaded that shit, so that's why I got that notification. So exercise 2, right? Suppose that this, right? I think we remember this. So we have this stuff, and we got to find P of 0, 1, 2, 3, right? And then you plug 1.5 into it. Okay, so for this one, I kind of remember. Samuel, you kind of remember this too, right? I mean, I kind of get it, but I'm not sure if I like remember it that well.
Which one?
The one where
that one, yeah.
Exercise 2, yeah, like this, right?
Yeah, I remember that one. You want me to explain it?
Yeah, go ahead and well, actually, yeah, you should explain it because I've been explaining all this shit. So it's like, you gotta be my slave for a little bit,
The fuck?
Yeah. I don't know. Like, how would you explain this?
Let me see. I have it here.
Yeah.
Okay, so let me get the paper. Okay, so first thing is actually I don't know. Should I say? I'll send mine in.
Yeah.
I don't know.
Oh, how
why
about
I
this? So you want to share your screen and show it? Like
Exactly.
show like your exam, right?
Yeah.
Okay.
Hold up, let me send it to my God. Let me send it to Discord.
Oh, by the way, are you allowed to share your screen?
Let's see. No, disabled.
Like, bro, it's like, bro, Zoom is on crack, bro. Like, I don't know what's going on, bro. Allow oh, sorry, bro. Yeah, you should be able to do it now.
Wait, okay, here we go.
Yeah.
I just sent it into the group chat. I doubt anyone wants to say anything. Hey, where is that? All right. Let me open it up. and share my second screen because I got 2 screens. So the fuck was that?
Yeah. Yeah, we
Yo,
see it.
give me 1 second. I hear something in my backyard.
Todavía no está aquí.
Yo, guys, I am so fucking hungry, man. I want some Chipotle.
Sorry about that, guys. I heard a
Go for
scream
it,
in my
man.
backyard. It was a cat. About to shit myself. I was like, fuck. All right. So you guys can see the screen, right?
Yeah, we can see it.
Okay. So everything you see here, this part, the P0, P02, P013, that's given to you.
Mhm.
So you want to find P0123 of 1.5, and then the furthest they give you is the P013 of 1.5. So that means you want to find whatever is not in this one. So that would be 201, 201, this one. You want to find this one. So
Yeah.
The way you know is by you set up this is called Neville's triangle. Okay. So you set it up and then you go X0 and then P01, P1, P23. And then you start combining these, right? You make little combinations like triangles. You make like that, right?
Yeah.
You guys see what I mean, right? Yeah. And then you get to the last two, and the last two make the last one. And then at the last one, that's when you actually rearrange the numbers. You guys remember one that we would have to like rearrange the numbers?
Yeah.
Is this one? Yeah. So then you arrange these to this P013, and then you arrange these to P201, which are the ones that you're missing. So then what you want to do is you want to break down the one we're missing into two and then rearrange so that you could have what you see here, P02, P01. So you have P02 here, P01, and then you solve for 1.5. So that gives you that P20 gives you 3.5, and then P01 gives you 6.5. So then you solve, you do X minus XJ, and then times Q1 minus X I times Q2, and then you divide that by XI minus
Yeah, what's the
XJ.
Q1 and Q2?
Q1 and Q2 are these. So you could consider these Q, like these little things here, Q.
Mhm.
So when you're finding the 3-digit one, these two are your Qs, right? But
Mhm.
then when you're finding the 4-digit one, this and this are your Q, right? So, sorry. This, the one that we just found, the 5, and the one given are the Qs. So you can think about it like this: when you're solving for a 3-digit number, the 2-digit one is the Q. When you're solving for a 4-digit one, the 3-digit one is a Q, right? So and then these are just the X minus XJs. I wrote here IJ so you guys can see it. And then by plugging in the X's and the I's, and then you plug in the Q1, which is the one given, and then Q0, which is the one we solved here. It gives you 4. This should be 4.5. It's 4.5. And then that's this one, P0123 of 1.5. It gives you that.
Yeah. Yo, actually, I got the answer for this. So yeah, let me actually show you mine because mine actually has the right answer. 5.5.
5.5. I
Yeah.
got 4.5 each time.
Yeah. Well, let me yeah, if anything, I can just
Damn, Joe, are you calling me dumb?
no. I don't know. I really don't know what to say to you, bro. Yeah, let me show you mine actually. Let me just see. Yeah, so mine is 5.5, bro. Yeah. Yeah, so yeah, just like you were saying, right? What I did was a little bit different because I just I already start off with the with that shit or no, okay, yeah, forget about this. This wasn't important, but so starting here, I already kind of changed it like that, 2013, right? I did what you did. Yeah, same thing, right? So I plugged the stuff in, right? Because it gave us that. Yeah, it's important. Yeah, that's another thing too, because I remember when I was first confused about this, about the whole I and J thing. Like
Yeah.
I is telling you like it's the number all the way to the left, right, of this P, and J is all the way to the right. And so the idea is that I and J are specific numbers, right? Or specific like indexes, right? So 1.5 minus 1. Shit. Let me think. Wait, why is it? Wait, hold on a second. So this is oh, okay, now I see it. So 1.5 minus the 1 here comes from the fact this is J, right? So it's this exact
Yeah.
right. So that's where the 1 comes from. The 3.5 comes from the fact that it's P of all the like numbers, not including the 1, right? So it's P of 20 or 02, it doesn't matter, right? So this is going to be 3.5, right? And then minus the
Yeah.
opposite, right? So this is going to be P of, okay, well, first of all, the 6.5, that's, oh, never mind. So 1.5 minus x of I, xi, so that's where the 2 is from, right? So, and then times P of all these other numbers except the 2, right? So it's gonna be P of 0, 1 or 1, 0, right? Either one. And that's where the 6.5 comes from. So you like bring it into there. And then it's gonna be 2 minus 1, right? So I minus J, right? That's where that comes from. And that's pretty much it, right? And then the 1.5, this comes from the fact that it's P of, well, this stuff, P of 1.5. So that's where the 1.5, that's where the 1.5 comes from. Yeah. And so it's like you
Well,
do that. I mean, you're
similar
doing it twice,
answers.
right? So that's
Yeah,
all
yeah.
it is.
Similar answers, off by 1. I think as long as you get the method right, you'll be fine probably.
Yeah. How many points did you get?
10. I got perfect score on that one.
Oh, okay. Okay. Yeah, I mean, yeah, okay, that's pretty much it, right? So is that good, guys?
sounds
The
good.
last one for that one is exercise 3,
Yeah.
which is just show how a2 equals x0, x1, x2.
Wait, let me actually read that real quick.
You
Okay,
remember
so
though, or no?
oh, okay, this is a proof actually. Yeah. Yeah, I did this one. Yeah, I did good on it. Let me see. Oh shit, yeah, you can't really see like, let me see, because I have the paper in front of me. Okay, so what that is, okay, so it's basically just f of x2. That's all it's saying. F of x2. Okay, so do you guys understand like this proof, like where it comes from or whatever? Like,
Yeah, it looks the same as mine almost. So this is the formula you see right there is it's the Lagrange. You're
mhm.
just doing the f of x over the x, right? So if you have f of x2 minus f of x1, you do f of x. Sorry, if you have f of x0, x1, you do f of x1 minus f of x0, and then over x1 minus x0. So it's just that, right? That gives you the f of x that you're looking for. But then
Yeah.
when you want one that's like skipping a number like 2 and 0, you do it like that. You do the highest number minus the lowest number, and then the highest minus the lowest on the bottom. That's basically how you get it.
Okay, yeah, so right, so so basically this is a proof. I'm not sure if we're gonna get tested on this. I feel like it would be weird if we did, but
Hopefully not, bro.
yeah,
It's cool.
whatever. I'll cover it at least, right? Just to be safe, right? So this is shit. Okay, so this is gonna be f of x2, right? So it equals f of x2, so that's in brackets, right? Since we're
Yeah.
dealing with like this Neville thing. So it's gonna be f of x0 plus f of x0, x1, x2 minus x0. I'm not sure where that. Wait. I think he gave that to us, right? Let me see.
Yeah. That's the actual formula. It's f of x0 plus f of x0, x1, x1 minus x0 plus a2, which a2 just means f of x0, x1, x2. That's all it means.
Yeah, no, I'm confused because why would it say x1?
No. You made a
Yeah.
mistake there. You made a mistake there.
Yeah. Okay. That
Yeah,
okay.
you made a
Then,
mistake there.
but I still got full credit though. That's kind of weird. Okay. Yeah. So yeah. That makes. Wait a minute.
Because
Why would it be, wouldn't it just be x minus x0?
if you look at the actual paper, like the front, it's x minus x0 plus a2 x minus x0 x. Remember, it's x's. The first one, like when you're actually solving for it.
Oh,
X.
wait.
You
Okay, I get
remember?
it now, right?
You get
Because
it? Yeah.
I'm plugging in x of 2. So
Yeah,
that's why
you're
x
solving for
pops up
x.
here where it's just x, right?
Yeah.
Okay. Yeah, so it is correct. It is correct. It's just that I'm kind of skipping a step. I'm skipping a step there.
Yeah. You're good. You're good.
Yeah. All right. So that's okay. So that's correct. That is correct. Okay. So this is what we get. So then what we do is that okay, so what we want to do is that we want to isolate A2, right? That's the idea. So we subtract all this other stuff to the other side. So f of x2 minus f of x0, all that stuff, right?
Yeah.
Then, okay, so then we divide on both sides, right? So we can, separate it, right? So there's your A2. Then, you have to do a little bit of algebra here, right? So basically both these guys are divided by x2 minus x0, x2 minus x1, right? That's just how it is. So on one hand, you have f of x2 minus f of x0, x2 minus x0. Well, obviously that's f of x2, x0, right? Like together like this, right? Or x0, x2, right? That's where that comes from, okay?
Yeah.
This is not part of that, right? It's just kind of there, okay? This is gonna hang out for a little bit, okay? So then you have this, and then notice that they have the same denominator, so that means that you can just kind of put them together, okay? And then you can rewrite this as x0, x2, x0, right? So you can just swap the order there. So this is just f of x2, x0 minus f of x0, x1, right? Over x2 minus x1, okay? So basically what you're doing here is that you're manipulating it in this way, so that way it's like in the standard formula of it. You know what I mean? So that way you can convert this to this, right? Which is f of x2, x0, x1, which is the same thing as f of x0, x1, x2, right? You can swap the order, and we do it that way, so that way it comes out like this. That's the idea. And so you're trying to prove that A2 equals that it equals f of x0, x1, x2. That's all it is.
Excellent.
Yeah, is that good, guys? I mean, it's a little like, it's like esoteric shit, but like, yeah, I mean, that's more or less what it is.
No, it's good, bro. It's good. So now we have exam 2 part 2. Let me see. That one I also got a 30. Oh, actually it was 15. Oh, I got 30 out of 50, sorry. Because I didn't do too good on number 4. You want to do it, Gerardo? It's basically divided difference. Or you want me to do it? Gerardo?
Yeah.
Oh, for some reason your volume got really low.
Oh, no, sorry, bro. It's just that I was standing up, so like, you hear me good now?
Oh yeah, I hear you.
Yeah, I was just saying you can do that if you want to. Like, you can share your screen.
All right, let's do it. Let me send in the picture to WhatsApp.
Yeah.
The
By the
only
way, so
part
we're gonna go over. I just want to say we're gonna go over like this one, exam 2, part 2, and then after that we'll be done, right? Because it's already been an hour. So
it's been an hour. Shit.
yeah.
Damn. All right, let me send it in, and then yeah. Then I gotta keep reviewing on my own still. Hold up, let me. The only part I got wrong was the error. I don't know why he said it was wrong. I literally did the error, but whatever.
Yeah. All right, you can share your screen now.
Got you. Let me go to WhatsApp. There you go. I'm gonna do this. I'm gonna download it because I hate when it starts moving around everywhere. For some reason, it just moves around. Okay, ready?
Yeah, go for it, bro.
You see it?
Yes.
All right. So this is the formula we're given. It's square
Wait,
root
actually,
of
can you show them like
the
like
question.
the question on the exam, like where it says like exercise 1 and then
Oh yeah, okay.
yeah, so that like we just want to know like the question. Like first.
No, yeah, I got you. Good idea.
Yeah. Wait,
That way
who's
you
that
know
guy?
how
Is that
to-
Richard Bone?
Richard Bronson, yeah, bro.
Who is that guy? It was like some old guy, right? Probably teaches physics.
Probably, bro. Is this one right? No.
Wait. Let me. No, it's not that one. No. It's the one where it starts off with like
This one.
square root
So
shit. Yeah, that's
it's
the one.
saying find the Hermit polynomial that interpolates f of x0 and x1. So if you get a Hermit, you could answer it using divided difference. He'll allow that. So Hermit, just use divided difference. So what you want to do is what you want to do is open this shit up. You get the equation, right? It's square root of x plus 1 plus e of x, right? So your equation is going to look something like this. P of n, and we're doing P of 2, right? Because there's two nodes, 0, 1, 2. You do P of n equals f of x0 plus f of x0 x1 times x minus x0. It's basically like the Lagrange that we just did right now.
Yeah.
If you look at it, how Gerardo set it up, it's the same concept. So, but it's just divided difference. So what you want to do is set up an x and fx table where you get your 0 equals 3.7182, right? You plug in 0 here, that's what it gives you. Plug in 0.5 gives you that. Plug in 1 gives you that. So your f of x0, x1, it's the same thing. Same formula. Do f of x0 minus f of x, f of x1 minus f of x0 over 1 minus x1 minus x0. So
Or wait, can you also do it as like f of x1 minus f of x0 over x1 minus x0? Is that also okay or what?
I think you could switch them as long as you know you get your sign correct. But I'm pretty sure it's f of x0 minus f of x. Okay, so let me see my formula sheet.
Or is it like is it the same way as how it was like when we went over exam 2 part 1, like the last question? Was it is it
Yeah,
the
that's what I
same way,
think
or is it
because
something different?
it's, I mean, this is divided difference. So let me
Yeah.
see. So it's f of x0 minus f of x1 minus f of x0 and then x1 minus x0. That's the formula.
Yeah. Oh, wait, let me see. Yeah, that's weird because like for some reason, like I think no, because the thing about divided difference though is that you use z, right?
Yeah.
Yeah.
Z0, Z1.
Is that what you did there or
Uh-huh.
like
Yeah. You basically do let me see. You basically do this. So you have Z0, Z1, Z2, Z3, then you have X0, X1, X2, X3, and then you have f of x0. It's kind of long. F of x1, f of x2, f of x3. And then you start combining. So then you know f of x0, f of x1 is x0, x1. So you do f of x0, x1, right?
Mhm.
And then this one is these two and then these two, right? And
Yeah.
then when you get this one and this one, for example, you know you have f of x0, 1, and then 2. And then that's how you know, like, for example, if you're getting, for example, x0 and x1, then you know it's going to look like this, right? But then if you're getting x0, x1, x2, then it's going to look like that. That's basically how you, like, kind of remember how it works.
Yeah.
So then, yeah, then you have, sorry, did I do the same here too? Let me see. Because I've been redoing them, so I also have it written down in my notebook.
Yeah.
So I made a mistake there. F of x, so it's supposed to be f of x0, and f of x0 is actually 2. So this right here is actually a 2. So it's 2 plus 1.746, which is what I actually got after. This one is a little bit inaccurate because this is supposed to be 2, not 3 point. Actually, let me see. For some reason, it's square root of 1 plus e to the 0 just gives you 2. So it should be 2.873 minus 2 over 0.5 minus 0, which gives you 1.746. So then you just follow the formula, right? You do f of x0, so you put, this will be 2, so you put 2 here, plus f of x0 x1. So we just looked at my formula, so it's just x1 minus f of x1 minus f of x0 over x1 minus x0. So then you put the 1.746 here, and then you put whatever number you're solving in here. I was solving for 1 because it was asking us for the interval 1. So I put 1 minus x0, which is 0. And then it's supposed to give me 3.746. And then the error is simple. The error is just it's 1 over 4 factorial times x minus x0 squared times x minus x1 squared. And again, if you go to the question, it was asking for f of 1 at the interval of 1. I was talking about it interpolates at 1, so that's why I found 1 here, and why on the error I did it x equals 1 here. And when you complete it, this is your final answer. Once you plug in everything. For the error, guys, just remember it's n plus 1. So this was 2, so it's the third derivative. But divided difference is pretty simple as long as you remember the formula. You just go adding one by one, right? Sound good, guys?
Yeah.
All right.
Yeah. Wait, let me just look at the question because I have it here.
Yeah,
you got an 8 on that question.
yeah, because he said I did the error.
No,
wrong
I'm not
for
trying to
some
roast you, bro. I'm just saying like you got an 8.
roasted me.
I think I got a 12, and I think you rewrote it as 14 or some shit.
Okay.
Yeah.
Are you trying to roast me?
Yeah, of course.
Wow.
No. Yo, but seriously though, I mean, it's pretty straightforward. I mean, it's not that complicated. I mean, it's a lot of writing, obviously, but I actually ended up with wait, let me look this up. So Hermit. Okay, yeah. So for that, so what was the Hermit polynomial you got? Can you show that again?
The Hermit, yeah.
Like your P of X equals like, what is that?
I got you right now.
Yeah.
Let me open up WhatsApp again. I close it up real quick. So which one did you want to see?
Like exercise 1.
Exercise 1?
Yeah,
Yeah,
exactly,
this one, the one that we're just doing.
Yeah. So where's your P of X?
P of X.
No,
what
because
do you
the
mean?
question asks you what's the Hermite polynomial. So it has to be like some sort of like P of X. You know
Oh
what I
no,
mean?
I just did divided difference.
No, I'm saying, yeah, but the thing is that the question is telling you, okay, let me read the question. So it says find the Hermite polynomial P that interpolates F, right? So it's asking for the polynomial. You know what I mean? Like it has to be something in terms of X, right? Like what I have is so here's my P of X. When I did the question, I got P of X equals 2 plus 1.5x plus whatever. I'll just like in fact, let me just like take a poll.
Oh, Gerardo, you're talking about my P of 1. No. Remember it. Hold up. So go to my screen. You see where it says P of 1? It's this. This is the polynomial you're talking about. So it's 2 plus, right? So this will be a 2 plus this was the actual this, right? So instead of putting all this in here, I just condensed it into the answer. You get me?
Yeah. Okay. So yeah, if anything, what I'll do is I'll just send in the yeah, I just sent it into the general chat. Let me bro, can you stop sharing your screen?
Sorry, bro. Damn.
Yeah. No. I'm just saying because I want to share my screen right now. Let me yeah. Okay. So let me go back to Zoom. I mean yeah. Okay, this, right? Okay, so this is what I did, right? So the same question, right? So the P of X is f of z0 plus f of z1 z0 x minus x0. Basically, you go all the way down. So you get no, actually it's just 3 terms, right? F of z3, z2, z1, z0.
0, 1, and 2 are they're all
Yeah. Because the thing is that you only have 2 nodes, right? X0 and X1. So that's why you have these these 2 other terms. You know what I mean? So okay, so this is the one with Z, right? So this is where you get this stuff. Okay, so what I'm saying is that okay, I know that it's wrong technically, but I probably messed up. Basically, the P of X I got was 2 plus 1.5x plus 0.26 x minus 0 x minus 0.5. Like that is my Hermit polynomial. You know what I mean? Yeah. So basically I got that as like the overall polynomial. So like if I wanted to know what is like an approximation for, I don't know, like what's like a approximation for like, what if I plugged in like x equals 0.2, then I'll plug in 0.2 into this, right? And I'll get an approximation, right? So I mean, that's what I did. And wait, let me see. Yeah. Yeah. Wait, how did I do this? Oh, okay. Yeah. So it's like, okay. Because what I have is very different from what you got, is what I'm trying to say. So it's like, it looks kind of weird.
I mean, maybe that's why I didn't get full credit.
Yeah. And then the remainder is just, it's the same thing with like the Lagrange, but this time it's like 2 times the n, right? Plus 2. And then same thing, but this time it's like you square it. And instead of f, no, it's the same thing. Just like this. It's like whatever is in here, it's like that's for the derivative there. So yeah, I mean the error is pretty okay. I mean, it's like the same thing, right? I mean,
It's just 1 over the 4 factorial.
Yeah.
But
Okay.
bro, it's all the errors we have to memorize. That's the problem.
Yeah, I know, but
like just for the rules, the midpoint, etc. All that's 6 different errors and 6 different formulas we have to memorize, So it's
yeah. All right, so let's go over exercise 2 for the let me stop the share. Yeah. I mean, you did a lot better on that part too, because I got like a 28 and I think you got a 38, right?
I got a 30,
Yeah, bro, go for it. Yeah, share the
oh, the
like
thing
question
is
2.
for the cubic spline, I mean, did he give me full points on it? It's 10, right? 10 points. Okay, he gave me 8 points on the cubic spline because I didn't get the 6th condition right. But on the natural cubic spline, I got full points because I did the condition right.
Yeah. Oh, actually, I ended up with yeah, it's kind of weird. I ended up with 10 points, even though he still gave me an X. So I think what he's saying is like my final answer is wrong, even though like I did everything right.
Probably.
Yeah. Go ahead. Like share your question 2, dude.
The clamp though, right?
Clamp. Wait, let me see.
Because
Yeah,
remember,
yeah,
it's
it's clamped.
clamped. And okay,
Yeah.
and then I guess I'll do natural too, because that one's the one I got right. Okay, let me send a picture.
Yeah. Bro, like for sure, we're not going over the last question because it's like
Dude, I'm not going over. I don't even
none
know
of
what
us knew how to do that shit. So it's like he's not gonna give that to us, right?
Yo, he better not. Because
Yeah, we
we're
can
only
bribe him,
getting
bro. It's
we're
fine.
only getting like look, we're only getting like 8 questions for this guy to put that and then we get it wrong. Come on, bro.
Yeah.
Okay, I'm sending it in now. Where did Simon go? Simon, where are you?
Bro, Simon just disappeared, bro.
Bro, Freddie has an obsession with that guy. Hold up, I'm opening up the picture now.
Yeah. Yo, I'm recording this, by the way, so that means that you know,
Oh my
everyone's gonna laugh at your ass, bro.
Bro. Yeah, no one ever watches it anyways.
What? Oh, how about this? What if I upload it on my YouTube channel? What about
Oh
that?
yeah, bro. Yeah, even better, bro. They'll hear me go, yeah. All right.
Yeah, might as well, right? I mean, it's a math channel technically, but sure.
Come on, shit.
Yeah.
All right, guys. So here we go. This was the question. Where did I put the question? So this is asking for clamp. Again, I'm not that good at clamp, so I did it wrong.
Yeah.
Like I did the last condition wrong. So is this S of x0, and then you have that equation and the bottom equation, right? But it will tell you clamped. And then I think this is the sixth condition, f of 1 equals f of 3. I think that's the sixth condition that is the one that like defines makes it clamped. So the first
Right.
condition is that it's continuous, right? So to check that, you just go to the interval and then you see it ends here at 2 and it continues at 2. And this one is 2 inclusive. So that's how you know that it's continuous, you know.
Yeah.
That's an easy one to understand. So next
Wait,
one
isn't
is
continuous? Doesn't continuous mean like also that there's no jumps in the function? Like
yeah.
if you wanted to check if it was continuous, you would like because notice the intervals they overlap at 2, so maybe like plug in 2 for like both those functions, and that's how you prove it as continuous, right?
Yeah. So yeah, that's usually I just look at it, and if it continues at 2, you know, so the second condition is plugging in 2 into each one. So when you plug in 2, this is your S of x0. So if you see here, you plug in 2 here is just 1. So it's 3 times 1, 2 times 1, 1 minus 1, sorry, and then minus 1 here. So this is what you get. You get 3 plus 2 minus 1, that gives you 4. And then when you plug in 2 here, this cancels out, that cancels out, that cancels out. All you have is A. So because you're setting them equal to each other, you get A equals 4, right? So A equals, and then you get 4. You're setting them equal to each other. The next step is the derivatives. So I wrote down here the derivatives so you can see it. So the derivative of 3x minus 1 is 3. The derivative of 4x minus 1 squared, 2x minus 1 squared, you bring down the square to 2. That makes it a 4x minus 1. And then this one was x minus 1 times, sorry, 3x minus 1. So then you bring the 3 down here, lower the 2, you know, derivative. And then same thing with the b, you just take the derivative here. Now for the s0, the s of 0 prime, it gives you this 3 plus 4 minus 3, that gives you 4. And then when you plug 2 here, you get 0. When you plug 2 here, you get 0. So you get b. So you get b equals 4. So now you know a and b both equal 4. So now the second part is you take the fourth condition is you take the second derivative. So it's the same process. You get the derivative and then you plug in 2 again, right? So then you get 4 minus 6. 4 minus 6, that gives you negative 2. But when I did it again a second time. And on my second time, let me tell you right now. Yeah. So my second time I got 4 minus 1. That gives me -2. And then for S of 1, it was 2C. So then I got -2 equals 2C. And that means that C equals -1. Because this D, I forgot that this D, when you plug, it cancels out. So I did it a little bit wrong. So yeah, it was just -2 equals 2C, so C equals -1. This here should actually be an X minus 2. That's why I messed up. So now we know C equals -1, B equals 4, A equals 4. Then when we go down to condition 5 is the left endpoint equals the right endpoint. So 1 equals 3, right? Right now we were just checking the continuous point. The continuous point is the middle, the one that has both. Now we're checking the left end and the right end. So the left end and the right end, when you plug in 1 into the first equation, so the first equation, remember, it was everything -1. So -1, -1, -1, right? When you plug in 1 to everything, you just get 0. And then when you plug in 3 here, you get A plus B plus C plus D, right? So when you get A plus B plus C plus D, 0 equals A plus B plus C plus D. Remember, A equals 4, B equals 4, C equals -1. So then you get, you move D over. And when you move D over, you get D equals -7. This was another mistake, but yeah, if you add if you add -1 plus -7, it gives you -8 regardless. So in a way, I was kind of right. But yeah, D does equal -7. And then the sixth condition, the sixth condition is where I fucked up. That's why he didn't give me the full points. This one I didn't know how to explain it, so I just kind of like, you know. Gerardo, if you could go over the sixth condition, bro, I'd appreciate that, man. Because
the sixth
I don't remember.
condition.
The sixth condition for clamp. That's the one I never really got good at doing. You know what I mean, right?
No, I don't think it was. Well, wait, let me see. Yeah, I don't think it was really necessary to like go over that because, like, yeah, I know like you have to verify the conditions and everything, but like, shit, I don't really know. Like,
if I have everything, I mean, that's why he took the points off. I mean, but I mean,
we pretty much know what to do, right? I mean, in this case, it was clamped, right? So that means that like, no, actually, wait. Oh, okay. I think I know what the condition was. So it was the one where it's clamped. So that means that f prime of some xi equals s. Wait, f.
It should be
hold on a second.
f prime of 1 equals f prime of 3. So f prime of left end equals f prime of right end. But isn't that regardless the sixth condition anyways?
Well, I'm not really sure though. I mean, it's kind of. I mean, I haven't reviewed like clamped in a long time, so.
All I know is that if he gives us this one, like if he gives us a natural spline, that's an easy A for us because you know it's very like George. Did you understand how to do it or no?
For the climb, yeah, I just did it wrong on my end. I only got like 5 points for them.
No, but now you understand, right? Like at least you at least understand the first 5 conditions of both, right?
Yeah.
Okay,
Yeah,
so you
it's not
see,
that
it's an easy A. It's just solving the two-way equation is all. For the cubic spline, it's the same thing. For the natural cubic spline, but I'll go over it regardless. I got the same thing I think as my exam. Let me see.
Yeah.
What it is. It was 10 points, right? Yeah, it was 10
Yeah,
points.
it's 10
So
points. Yeah.
yeah, this one I got 4 points. Okay. But regardless, I'm gonna send it in here.
Yeah, bro. So yeah, we're definitely not going over question 4, brother.
Hell no.
That's just cancer, bro.
Oh, Gerardo. People are hearing you, bro.
Yeah.
Can't use bad words, bro.
I don't know about word, bro. It's cancer.
the
That's one of
fourth
the. That's one of the. Shit, what are they called?
The zodiac signs, bro.
Yeah, zodiac sign. Yeah, exactly.
Right,
But what you
zodiac
think?
sign.
What you think? Capricorn is a cuss word too, bro.
Yeah, how'd you know? And Aquarius, bro.
Aquarius.
What else?
I don't even know what my zodiac sign is. Probably forgot it.
When were
already.
you born again? You were born in March, weren't you?
No, October.
October. That's right. Who was born in March then? I remember someone born in March, whatever. October, I think you're a Scorpio, bro. All right, guys. So this is the cubic for natural. So
Yo, we don't see your screen, dude.
you don't see my screen?
No.
The fuck?
Yeah, now we see it. Yeah.
Okay, so let me put first Gerardo.
Bro, why you zooming in on me, bro?
Come on, man. What the hell is this? Where is this? There we go. It was. Where is it? Where is it? Is it this one? No. This one. Okay, so notice the difference of this one and this one. This one we have A, B, C, D. This one we only have B, D, B, D. So I think if you get, like, if it doesn't tell you, I guess, you know, if you see B, D, B, D, it's natural. But yeah, it's the same situation, right? You have a continuous function that you know is continuous because you have 1, 2, 2, 3, and then you have your little points here. The points, I didn't really use them at all, but yeah, this is your first equation, your second equation, and then this is your interval. So now we could start. So first thing I did, I moved it to condition 4, was that the interval is continuous, that it goes from 1, 2 to 3, which you see here, 1, 2, then it goes 2 still, and then 3.
Yeah.
The second thing I did was I checked if the continuous point, which is 2, right? The point where like both of them have that number.
Yeah.
I set them equal to each other. So then when you do that, you put 2 here instead of x, 2 here, and then you get 1 plus b minus d. And then when you do that here, these all cancel out. So then you have b, 1. So you have 1 plus b minus d equals 1. So then you get b minus d equals 1. You get b minus d equals 0. And then when you add d to the other side, you get b equals d. So whenever you find b or whenever you find d, you know the other one. That's third condition is set the prime of the midpoint of the continuous point right here. Set it equal to the S1 prime. So when you do that, you get the derivative of this one is just b. You get the derivative of this one is 3d. So again, you get b minus 3d, and then you plug in 2 here. You get b minus 3d, and then this one, because you put 2, 2, 2, it all cancels out. Sorry, you get this one disappears. This one multiplies, and then it's minus 2, 2 minus 2, 0. And then this one just stays as b. So you can set it to b, big B minus 3d equals b. So when you move them aside, you get b, little b equals big B minus 3d, right? And then this is the one where you start understanding at the second derivative. So you get again the second derivative of S0 at the continuous point equals S1 second derivative of S2 of 2. So when you do that, this completely disappears, and then all you have left is 6d x minus 1. So when you plug that in, you just get 6d. And then this one, when you take the second derivative, the only one that stays is well, they all disappear actually. So you just get this 6d x minus 1. And then that was equal to negative 3 over 2, because when you multiply this one out, it becomes negative 3 over 2. So like when you get the derivative, I mean. So then you divide negative 3 over 2 by 6, and that gives you d equals negative 1 over 4. And now we have big B as well. And then now we do the left end and the right end, right? So you get the left end and you sub in 1, and then you sub in 3. And then that gives you that d equals 1 over 4. And then in the last one, I just confirmed my theory that b equaled negative 1 over 4 by doing the derivative of 1 and 3. As you can see here, b did equal negative 1 over 4. So I got all my numbers right here.
Yeah, and you got full credit on that one?
Yeah, 10 points.
Oh shit. Yeah, that's the weird thing because I think I did what you did, but like I probably screwed up a little bit. When I got big B and big D, I got both of them as 4, not -1/4.
That's funny. I got -1 for big B and little
Yeah,
b.
that's the thing. It's like it seems like everyone just got like different numbers for this shit, and it's all
For
like
the entire
what,
process, did
algebra or
everything
what?
right. It's just yeah, the algebra part I just fucked up on, like solving for the variables. I just got them all wrong. But the whole
Yeah,
process
bro,
was
it's just
right.
my brain. Yeah, probably just our brains were like freaking like when
Yeah,
we saw question 4 before we did any of the questions, we were just like, oh shit. Like,
threw
Yeah.
us off.
yeah. Yeah, that's basically it, right? I mean, that's pretty much it. As for right now.
It's all right, bro. We'll keep getting